Application of vectors. The scalar product. For two vectors, let's call them v1 and v2, with an angle of theta between them, the scalar product, or dot product as it's often known, is given by v1 dot v2 is the modulus of v1 times the modulus of v2 times the cosine of the angle between them. Note that we're doing an operation between two vectors that produces a scalar. The answer on the right hand side is just a number. Although in most situations it won't be important for you to know this, it's worth including what we actually mean by the angle between two vectors. Here we have two vectors which are coming outwards from this point. The angle between them is this angle here. Here we have two vectors going into a point. The angle between them is this angle here. However, if we have one vector going in and one going out, then strictly speaking, the angle between the two vectors is this angle here. Although very often we don't need to know this distinction because we're often asked for the acute angle between two vectors. So if we do the dot product and we get an acute angle, that's the answer. If we do the dot product and we get an obtuse answer, then we just do 180, take away that answer. Find the scalar product of vectors with magnitudes 3 root 3 and 6 at an angle of 45 degrees to each other. I like to write the formula as a dot b is the magnitude of a times the magnitude of b times the cosine of theta. If we say that this one is our vector a, then it has a magnitude of 3 root 3. If we say that this one was the vector b, then its magnitude is 6, we're being given that, and the angle between them is 45 degrees. So we just need to calculate 3 root 3 times 6 times cos 45, and that would give us 22.0, correct to 1 decimal place. If we wanted it as an exact answer, this would be 18 root 3, and cos 45 is root 2 over 2. 18 divided by 2 is 9, root 3 times root 2 is root 6. So the answer is 9 root 6. If a is equal to 330 and b is for 330, so these are in polar form, calculate a dot b and verify your answer with the CAS calculator. So if that's the positive x-axis, 30 degrees means up here, and that one has a magnitude of 3. 330 is all the way round and 30 degrees before we get to 360. And this one has a magnitude of 4. So the angle between the vectors is 60 degrees. So a dot b is going to be the magnitude of a, which is 3, times the magnitude of b, which is 4, times the cosine of the angle between them, which is 60, and that works out to be 6. Using the CAS calculator to calculate the dot product, look at the calculator guide, and now you can do exercise 4.01 on page 116 of the textbook.